So, the for loop, we will see, it allows us to execute a set of statements until a certain condition is satisfied. So, here again you have a certain condition, and based on its validity, whether it is true or false, according to that the set of statements are executed. The condition can be predefined, either we ourselves can define the condition before the starting of the loop, or based on the execution of the loop the condition can define itself, it can be open ended. For loop has many forms, that is, it is not necessary that all the terms and steps or all the parts of the loop have to be present in every execution. Sometimes we may leave some part undefined also, based on that the loop will execute. But whatever may be the case, we have to define the syntax properly, otherwise the loop will go on executing without any control, that is called an infinite loop. So, general syntax of a loop is the for keyword. Initialization counter is nothing but giving the value to the loop variable, the initial value. Test condition is whatever condition has to be checked each time, and the revaluation parameter is the updation of that loop variable. Each time the loop is incremented or decremented, the loop variable. And as again we know, within the set of curly braces we have the statements that are to be executed if the condition satisfies to true. So, the initialize counter, what does this initialize counter mean? As I said, it sets the loop to its initial value, the loop variable, and this statement is executed only once. So, this statement is not executed each time we execute the set of statements in the loop. At the beginning, when we execute the loop for the first time, we give an initial value to its variable. The test condition is nothing but the relational expression that determines when to exit from the loop. Based on the value that we get as a result of executing this expression only, the compiler will decide when the loop has to complete its execution, because it is going to repeat a number of times. So, how many times should the loop repeat? There has to be some control on that. So, that depends upon this relational expression only. The for loop continues as long as the condition is true, and when the condition turns false, the control exits from the body of the loop. Exits from the body of the loop in the sense it comes to the set of statements that follow the closing brace. So, the opening and the closing brace only indicate the scope of the for loop. Any statement after the closing brace indicates the ending of the body. The revaluation parameter, this is what decides how to make changes in the loop, that is the updating the value of the loop variable. So, every time the loop variable is updated, either it is increased or decreased. So, that causes the revaluation of the condition. So, the first time the condition is checked, after the loop is executed, the variable is updated, again the condition is checked, and then the compiler decides whether to execute the set of statements or to exit from the block. So, this is how a normal for loop operates. Now, these are the different forms of the for loop. If you see the first case, you simply have the for keyword and you have within parentheses simply 2 semicolons. Neither is the initial value defined, nor the expression, nor the updated value. So, the ultimate result of such a loop will be infinite execution. Infinite means no control. There are no arguments, no variables, nothing. So, the compiler will not know where to start and where to end. It will simply keep executing the loop over and over again. You will not get any output. You will simply see the screen being refreshed again and again. So, this is something that is not generally used in programming. The next case is where you have the for loop. You have the loop variable a is equal to 0 terminated by semicolon, and a is less than or equal to 20. So, here you have the first two cases defined. You have the loop variable a, you have the initialization counter 0, you have the revaluation condition less than or equal to 20, and you do not have any updation. Like each time the loop executes, the value of a is going to remain 0 unless somewhere in the loop you are going to update its value. So, if each time the value of a is going to be 0, each time it is going to be less than 20, again the loop is going to keep executing time and time over again. So, that is also an infinite loop, and the remark is that the a value is neither increased nor decreased, it is not updated. So, this is also an incomplete for loop. If you see the third case, you have the loop variable is equal to 0, you have the condition less than or equal to 10, and you have the updation of a plus plus. So, here each time the loop is executed, the value of a increments by 1. So, the first time it is 0, second it is 1, third it is 2. So, like that it goes till the value becomes 10. After it becomes 10, it executes the loop again. Again when it updates the value of a will become 11. So, 11 is less than or equal to 10, that condition is false. 11 is greater than 10. So, at that particular point of time it will jump out of the loop. So, this is only the correct formation of a for loop. The fourth condition is just a different type of decrementing the value. The third condition we saw how it increases. The fourth condition is updation by decrementing. Again the loop variable is values initialized as 10 greater than or equal to 0 and the value of a is decremented. So, the first time it will be 10, next 9, then 8, 7, 6, 5 till it comes to 0. When it becomes minus 1, it will check the condition a is greater than or equal to 0, minus 1 is less than 0. So, it will obviously exit from the loop. So, these are the different forms of the for loop. Next you have a type called the nested for loop, which is nothing but one for loop inside another, a loop within a loop. One or more for statements are included in the body of the loop. That is, you do not have a single for, you have first for, second for, third for. Each for has its own set of statements, its own condition, its own variable, and the number of opening braces for each for loop should be correctly closed by the closing braces. Only then the compiler will not have any confusion about where each for loop ends. So, the for loop which is outermost is called the outer loop, the loop which is defined inside it is called the inner for loop. Always remember, the inner for loop will complete its execution, only then the control will go to the outer for loop. So, this is an example for a simple for loop where you are displaying even numbers from 0 to 14. You have the header file and the main function which is the starting point of the program. This is how every C program will start. You have the declaration int I is equal to 0. You have the clear screen which clears the screen. Now, how are you going to generate numbers from 0 to 14, 15? That is, you have to generate only even numbers. We know that it is 0, 2, 4, 6, 8. You have the limit from 0 to 15. So, from 0 to 15 all the even numbers have to be printed. So, here if you see this for loop, it does not have the loop variable, neither does it have the updation, but still the program executes correctly. It is having only the condition. Now, how is this possible? If you see here, already the loop variable is initialized as I is equal to 0. The initialization of the for loop is given over here, I is equal to 0. So, this part is over here. The next part if you see, so this section of the for loop is not required. Only the evaluation condition of I should be less than or equal to 15. And again the updation value is also not over here because this I plus is equal to 2. The value is updated here in the loop itself. So, according to the compiler, I's initial value is known, that is 0. It will enter the loop because 0 is less than 15, the condition is checked. It will printf %5d is nothing but just to print with space like this. If you see, the output is clearly spaced out well. So, only for defining the spaces this 5 digit is used, and %d and I is nothing but initially it is 0. So, 0 is printed the first time. The next step is I plus is equal to 2. This is nothing but I is equal to I plus 2. I plus is equal to 2 is the same as increasing the value of I by 2. So, first 0 is printed. Now, value of I is increased by 2 means 0 plus 2. Now, the value of I is 2. The compiler checks the condition, is 2 less than or equal to 15? Yes. So, it again prints 2. Then again the value of I is increased by 2, it becomes 4. 4 is less than 15? Yes. So, it prints 4. So, similarly 6, 8, 10, 12, 14. After 14, when the value of I is increased by 2, it becomes 16. So, when the compiler checks the condition over here, is 16 less than or equal to 15, it is false. So, automatically the compiler will jump out of the loop, close this for loop and close the main function. So, that is how this output is generated. This is a very simple for program, just to show you that even without declaring all the parts of the for loop, you can somewhere initialize a variable ahead and increment the variable in the body of the loop also, and still the program can execute correctly. The same program can be executed well if you define I is equal to 0, the place where I have marked with red, and if you increment I plus is equal to 2 in the evaluation parameter. So, these are the different ways in which we can program correctly using the C language. Now, this is a program for a nested for loop. We have seen about the simple for loop, this is a nested for loop. Here you are going to generate perfect cubes up to a certain number. For example, say I give the number 100, what are all the perfect cubes in that? 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. So, that 125 exceeds 100. So, there are only 4 perfect cubes from 0 to 100, that is 1, 8, 27 and 64. Now, I want to write a program where it will identify these perfect cubes and it will give the number I. Now, j is less than or equal to I means the inner loop's value should be less than the loop variable of the outer loop, and j plus plus, that is the incrementation of each cycle. So, here if you see the first step, now I is also equal to 1 and j is also equal to 1. So, the condition j is less than or equal to 1 is satisfied, 1 is less than or equal to 1. So, it enters this it enters the inner loop and it checks the condition is I equal to power of j comma 3. The value of I is 1, the value of j is also 1. So, it checks whether 1 is equal to 1 cube, 1 cube is also equal to 1. So, it accepts this condition and prints the value 1 comma cube. Now, that is how this 1 is printed, the number 1 and its cube 1, because here I is equal to 1 and j is also equal to 1, 1 is equal to 1 cube. And then it comes to this updation of the value j plus plus, now j becomes 2. Now, it checks the condition whether 2 is less than or equal to 1, it does not satisfy. So, it comes out of the loop and goes to the outer loop. Now, I plus plus, I is now 1, I plus plus it becomes 2, and it checks the condition whether 2 is less than or equal to 100. Now, the value of k is 100, whether 2 is less than or equal to 100 it satisfies. It enters the for loop, j, again the value of j is initialized to 1, checks whether 1 is less than or equal to 2, it is true, checks whether, now the value of I is 2, value of j is 1, whether 1 cube is equal to 2, no. So, it does not print anything, it increments the value of j to 2, checks whether 2 is less than or equal to 2, yes. So, it again comes in whether 2 is equal to 2 cube, 2 cube is equal to 8. So, again this condition is not satisfied, it jumps out of the loop, increments the value of j to 3, checks whether 3 is less than or equal to 2. So, this condition does not satisfy, it comes to the outer loop. So, now I becomes 3, checks whether 3 is less than 100. So, in this way the loop keeps executing again and again till this I reaches the value of 8. When this I reaches the value of 8, it comes to the inner loop, starts executing from the beginning, whether 1 is less than 8, yes, is 8 equal to power of 1 cube, 1 cube is not equal to 8. So, this will not be printed, j plus plus. Now, j will become 2, is 2 less than or equal to 8, yes, and it checks over here whether this 8 is, now the value of I is 8, whether this 8 is equal to power of 2 cube, 2 cube is equal to 8. So, then it identifies that 8 as a perfect cube and it prints the number 2 and 8. So, similarly till this I becomes 27, the loop will keep on be executing. Only when it is 27, it will identify it as 3 cube is equal to 27 and print the number 3 and 27. Until it becomes 64, till the value of I becomes 64, the loop keeps executing. Only when the value of I is 64, it identifies it as 4 cube is equal to 64. So, this is how nested for loops are used. I am using this outer loop to identify the cube and I am using the inner loop to identify for which number it is the cube, and corresponding to that I print the output. If you see the next number 5, the cube of I is 125, which is greater than k, because only till 100 we want the cubes, not more than that. So, this is an example for how nested for loops can be used. And remember, here I am having 3 braces, the inner loop is closed, then the outer loop is closed, and finally the main function. So, these things have to be kept in mind when we are using a for loop.